Next up, with the home field advantage, we have James Lucas, who is going to be presenting British Antarctic Survey Sediment Core Database and Data Portal. Just give me a moment and I'll bring up your presentation.
Okay, thanks. So I'm James Lucas. I work for the Polar Data Center here at BAS, and we'd like to present the new BAS Sediment Core Database. So just a brief bit of background about what sediment cores are. They are kind of tubes of sediment that are collected from the ocean, lake floor. At BAS, we've been collecting them for a long time. We've got in the new Polar Core Storage Facilities about 200 marine cores, which have been collected on 13 cruises since 1987, and about 300 lake cores and a similar number of peat cores that have been collected over 18 expeditions since the early 90s. These cores are scientifically valuable because they contain records of past climate through time. So again, they're kind of tubes of sediment. So by measuring sediment composition, lithology, biological assemblages, that kind of thing, you can see a record back through time. Some of the marine cores are very long and they can extend hundreds of thousands of years into the past. And as you can see, we've collected them from these maps from various interesting places, including the Great Passage, off the Thwaites ice shelf, and then for the terrestrial cores in various islands in the Southern Ocean, in the Larsemann Hills area of Eastern Antarctica. So it's a nice collection that we'd like to make more available to people in general. So yeah, that brings on to why did we need a sediment core database? Essentially, there were three intersecting reasons. So the first one is to make the core collection accessible to researchers outside of BAS. So it's not that much good just kind of having them here. Well, it's nice for us, but it would be better for everybody if it would be possible to search the cores that we have by geographic location, maybe even by analysis that's already been performed on them. We also needed it for us within BAS. We didn't actually have a long-term repository for metadata that had been collected with the core. So things like where was it collected, who was it collected by, actually tied to the core itself. So we needed a way to make sure that was stored past the time when the scientists who have it on their hard drive retire or leave or whatever. And finally, for collections management. So we've got a new Polar Core Storage Facility, and in tandem with that, we wanted a way to be able to tell where the core was, to easily be able to find it in our own storage. So start by, I should say, we built that using Apex, because that's what we usually use at the Polar Data Center, and we also built the web portals, exposing different parts of the database for kind of public and BAS users, again, using Apex. So to start talking a little bit about the public web portal, so as I said, this is to facilitate reuse of core material. So the core material is quite rare. It comes from a faraway part of the world. It was expensive to collect. We'll use it again. So the main way to search the BAS core collection is by this map interface. So it shows positions of all the cores that we have in BAS storage. You can filter based on the cruise number if you know it. If you press on the dot on the map that is the core, it pulls up a thing of additional metadata, so exact latitude and longitude, core recovery length, collection date. And then in the table at the bottom appears records of everything that corresponds to a dot on the map. And that is a searchable table, and it includes things like gazetteer. So you can search based on a gazetteer keyword. They are separated into marine and lake peat, kind of ease of access. We also have, it's not shown here, a kind of more advanced search where we use the faceted search feature that you can have in Oracle to, sorry, in Apex to search by collection date from time to time, or if you want to know what was collected by a particular collector. The metadata that we present in this public database meets the standards that would be needed to assign an international generic sample number. For those that don't know, that's basically to a sample what a DOI is to a data set or a journal article, so it provides a unique identifier. So key metadata for that is the type of sample, like its name, the latitude and longitude of its collection date, and its collector. So having all that information in our own database means obviously they're uniquely identified, and if we do choose to mint IGSNs, they're all easily in one place. And you can easily do that. So It's possible through the public web interface to find out even more information on individual cores by selecting the core itself. So here you can see this is a record from the recent core trials. You can see there's information about the core and then information about the sections that the core has been divided up into. Also on this page are links to scanned core descriptions and core photos. Right now, we've just populated scanned core descriptions because BAS didn't really have a history of taking core photos, but the new Polar Sediment Core Facility has a core photography station, so we wanted to integrate that into the database. This is a photograph of a core rather than a core photo, but you can get the kind of principle. It's useful to be able to see, because even there you can see there are different colors, there are different layers, and often if you're a researcher wanting to perform some research on a core, you can get a first order idea of how useful any particular one is going to be from what it looks like. So does it contain enough carbon, does it contain enough total organic carbon for whatever you want to do? That's the reason we wanted to present it on the database. Also attached to records of each individual core are links to datasets that have been produced using that core material. So we don't publish the data through this data portal, that's all hosted in its original places, but we provide a link through the DOI. I have to say this isn't automated. We populated this manually by looking through our own British Antarctic Survey metadata discovery portal and by looking at publications of the core collectors. In the future, it's possible for scientists to add these, and it's possible for communities to add these. It's also possible in the future, if IGSNs are more kind of widely assigned and cited, that it will become much easier to search for analysis that was carried out on a particular core. That's an advantage of IGSNs, because it would also be a way to see what's tagged with this kind of unique ID. Another way to look kind of a more broad overview of the analysis that's been performed on BAS cores. We presented that it's the same data, but it's presented in a table, which you can just see behind the map pop up. And that table is filterable by keyword of type of analysis, and it's searchable in a free text way by author name. So if you're looking for something specific, or you can look at that. There's also a kind of map interface, so that presents those dots again of locations of marine cores in the BAS collection, and you can filter based on keywords of analysis type. So up there's magnetic susceptibility, carbonate content. Pressing on one of the cores brings up a list of the types of analysis that have been carried out in linked datasets, essentially. So that's not all one thing, that's just all the datasets that are linked to it. These are the analysis types that's attached. The point of doing all this, we hope, is that it'll facilitate, well, first of all, the scientists at BAS asked us to do it, and secondly, we hope it'll facilitate kind of working, collaboration on the cores, because you can see what's already been done, you can see where other stuff has been done and what gaps there might be in kind of oceanographically interesting regions. And secondly, it prevents people doing the same analysis twice, which is a bit of concern for scientists, where sometimes analysis doesn't need to be redone, especially on such rare material, but it is redone because people don't realize that it already exists. So that was a concern that was raised that I hope this sort of addresses a bit. So secondly, I said that we said that we talked a lot to the scientists about what they wanted out of the database. So the very first planning meeting for all this was with scientists. We're lucky here in the PDC at BAS that we literally work with the people that are going to be using, the same building as people that are going to be using our database. So they were involved right from the beginning and kind of providing feedback through the project's work, because the most important thing essentially is that the database itself and the web portal are informed that people will actually use them, otherwise they're not. The sources of the metadata that we populated the database with were from spreadsheets that have been collated by the scientists over time. These had all of the kind of issues that you might expect from this kind of record, but they did allow us to see by the columns that the scientists has included what is important to them. And so together we could work out what's the kind of essential metadata that we need to collect to identify these cores uniquely, what's metadata that's useful long-term for scientists to hold on to, and we could build the structure of the kind of metadata tables of our database accordingly. Errors and gaps in those spreadsheets were filled in by going back to the original cruise reports, or quite often going back to the original scientists. Again, this is the advantage of working in BAS. People have been here for a long time. There are people that remember all of the cruises that have happened, but it was sort of good that we did it now. We very much felt it was good that we did it now before those people retired, because then we would have been fairly stuck. The second aspect of the kind of BAS interface was how do we make sure that in the future we're collecting and inputting consistent metadata into the database. So we took input from scientists on what metadata they habitually record and what's possible / reasonable to record in the field. Here again, it's really useful how integrated we are with BAS. Alice Fremond actually helped out with the coring whilst she was data manager on the coring trials, and so really got a sense of what doesn't make sense to us, data managers in an office, about why people do things a certain way. Makes a lot more sense when you're actually on like the wet, muddy deck of a ship with an enormous core in front of you that you're slicing into pieces. So that was valuable to take back into what we built. Essentially, the way that we decided to collect consistent metadata was templates, Excel templates. And Excel templates provided to terrestrial researchers, because that's kind of similar to how they already do it. But as previously mentioned yesterday, for people that are there, so David Attenborough, which is our research vessel, has a very well-used event logger. And so rather than make scientists fill out both the event logger and our own templates, which is going to take extra make work for them to do, we've written a script that means that we can extract data into our own templates from the event logger. And that was a success on the last coring trials. From the templates, we can upload into the marine database. And after it's uploaded, scientists have the ability to add extra information as they need. So for example, if they continue to work on the core and there's a particular comment they want to make, that's possible to do. They can link published data sets, they can upload core photos after the fact as well. That's kind of functionality that's in the database. The third and final thing is collections management. So cores in the collection have a collection status. It might be at BAS, it might be at another research institute, it might be destroyed if the core's been completely, destroyed for some reason or lost. Only cores at BAS are exposed on the public data portal to avoid people asking us about cores that we don't actually have, but it's useful for us within house or scientists within house to have a record of everything that we've collected and what happened to it. As you can see there's various filterable based on storage room. You can search by core ID for the location of something. And seeing Luke's presentation reminded me of it, that we also have created QR code labels. So the idea is that a QR code label can be pasted on any of the cores in our storage, and then when it's scanned, it takes you to a web page that we built that shows the metadata on the core. So again, it helps to deal with the fact that the cores aren't an infinite size, so you can't write all the information on it. Oh yes, sorry, I knew there was one more thing here. Built on top of this storage system is a transfer and loan system, which lets us know where things have gone. It's also important because it's government mandated in the UK to record information on the storage and the transfer and the destruction of terrestrial core material. So something else that this web portal does on the scientist side is provide an easy way to select a time frame and see everything that has been loaned or moved or destroyed in that time, and then export that to be sent out to DEFRA or whoever it needs to go to. So I talked a lot about kind of findability and accessibility. There's a little bit about interoperability. We want to make sure that things are as consistent as possible. So both between BAS databases, so we're building a marine databases, and marine event numbers are populated from that database as soon as cores are entered into the sediment core database, which means that it's got the same identifier in both, and you can tie it back to all the information that's in the marine database about that marine event. ORCIDs of core collectors and ROR codes were used, and we used external control vocabularies for coring devices. So we used the L22 net vocabulary for geographic regions, so we used SCAR gazetteer names, and for lithological keywords we used the BGS dot classification scheme. Finally, as we're at 15 minutes, I thought I'd just say a tiny bit about some of the challenges that this database, building this database included, because it's always interesting to hear about on other people's talks. A kind of, maybe the right word is semantic. Difficulty is that core actually has several meanings when you're trying to build a database that talks both about core metadata and core storage. When you're collecting a core kind of means the conceptually result of the coring event. So, you know, like where it was collected and all that kind of thing. Then when you store it, however, you seldom store it as one single physical object. It's usually divided into pieces, often in several different ways. It's not exactly an insurmountable problem. when you're trying to work out where a core is stored, you're actually just then trying to work out, well, where are its children stored and propagating that back up the chain. But I thought it was just kind of like an interesting ambiguity that was a result of essentially trying to make one database handle quite a lot of different, like surprisingly conceptual different things. The second one is like the classic balancing ideal metadata collection with reality. It's very easy to say, oh, it'd be great if people collected all of this stuff, but there's stuff that people can't or just don't really want to collect. So again, this was overcoming this challenge involved just not reinventing the wheel, like going back, seeing how do people already do it, which meant integrating with the event logger, kind of building our templates off existing templates to make sure that we get the mandatory stuff that we need, but without making, essentially without turning people completely off the system and having them divert back into their original things that artist completers would like them to do. Finally, just a note on control vocabularies. I personally found fitting custom-built coring devices that often change during a cruise or between cruises in a bit of a ship of Theseus type way, exactly defining where a model number is was a bit difficult. That's my last challenge on the topic of vocabularies, and that's it. So thank you very much.
Oh, yeah, you're fine. So questions for James, please, from the audience. Yes, Frank.
Very nice. So that's like the BAS collection. I know that, like for example, in the US, there is also Antarctic core collection at Oregon State. And did you? I mean, maybe it's a little early, but like, or have you plans to connect like the different things that somebody looking for a core here maybe can, say, just show me if there's any cores from other collections.
That isn't something we've done. That's a really cool idea and something we'll think about. Yeah, there's also other core repositories in the UK. This was trying to bring BAS's collection into the same level or maybe beyond the level of them. But yeah, that would be a really interesting thing to do, to be able to link to other places.
I think Geoscience Australia would probably be interested in the same, and they've been grappling with similar. So if you wanted to have sort of a meta view, there will be a number of partners you could look to.
Yeah, it's a really nice idea.
Any other questions from the audience for James? All right, I think they've let you off.